Okay, we've talked about a lot about linear systems, and we've actually graphed many different types of linear systems and lines. Never really talking about real world problems here. So let me go ahead and pull up a word problem. I know we all hate word problems, but let me pull one up that kind of defines why we need to talk about linear systems and how this is all going to work. So as I look at this, here's a problem we're going to try to solve right here. Place that right there. Problem says you bought a total of 6 pens and pencils for $4. If each pen costs $1 and each pencil costs 50 cents, how many pens and pencils did you buy? So the idea is to try to get two equations out of this little bit of a word problem. So let me try to identify some certain things. We've got pens, so I'll put pens in red, and we got pencils, and I'll put those in blue. I noticed that it says we bought a total of 6 pens and pencils, so that's a total number of everything. I know that pens cost $1 and pencils cost 50 cents. So technically, I could say X is my pens and Y is my pencils. Okay? Originally, right off the bat, I'll tell you that you bought a total of 6 pens and pencils. Well, there's an equation right there in and of itself. X plus Y equals 6. And this is based on the count of how many you have. Right? That's right off the bat. That's what the first sentence is. You bought a total of 6 pens. So there's one equation right there. X plus Y equals 6. Now let's talk about cost. Well, the word problem says that pens cost $1, so I could say 1x, right? So if I knew the number of pens, I could determine how much the pens cost me by just multiplying by how much they cost, which is $1. I could also do the same for pencils. I know that pencils cost 50 cents each. So this could almost be 50y. Because I know that pencils cost 50 cents. Now, this line right here says I bought 6 of them for a total of $4. I can make an equation out of that. I say the number of pens times the cost, which is 1 times x, this right here, plus, I'll put a plus in there, the cost of the pencils times the number of pencils will give me $4. So there's my two equations. Let me break these down into slope-intercept form because we're going to go ahead and graph these and see if they intersect. Top one's easy. Here we go. X plus Y equals 6. I subtract x from both sides. I get y equals negative x plus 6. So now let's talk about the other one. 1x plus 0.50y equals 4. So I'm going to subtract x from both sides. So I get 0.50y equals negative x plus 4. So far, so good. How do I get rid of a dollar or a 50 cent y? This is technically a half. I'm going to multiply everything by 2. How about that? Because in order to get rid of a half, right here, which is what this is, if I multiply by 2, that'll get rid of the half. So I'm left with, here's my equation, y equals negative 2x plus 8. Negative 2x plus 8, because I go 2 times negative x, 2 times 4 gives me 8. So there are my two equations. Negative x plus 6 and negative 2x plus 8. Let's move on to the next, and we're going to go ahead and graph. Let me load in a graph here. So there's my graph. We'll make that nice and big so I can see. And I got my two equations. I've got y equals negative x plus 6 and y equals negative 2x plus 8. So let's graph these. I will put line 1 in for red, and we'll go line 2 will be blue. So let's do red first, line 1. So I notice plus 6. I come up here to 6. I put a point. Let's talk about slopes for a second. The slope of line 1 equals negative 1, which is negative 1 over 1. Oops, 1. I could also, just to kind of extend this, I could keep going down one, over one, down one, over one, down one, over one, so on and so forth for a long time. But what if I said this could also be the same as, let's say, down 6 over 6. So let's do that. So if I go down 6, 1, 2, 3, 4, 5, 6 over 6, I get here. Okay, and there's a bunch of points in between, and we'll talk about that in a quick second. But I can put my line there if I want to. And I can actually, if you notice, all of these points that are on this diagonal are all part of the line. Okay, so this line's going to look like this. Down 6 over 6. So now let's look at line 2. Here we go with line 2. My y-intercept is 8, so I'm up here at 8. And my slope is negative 2 over 1, so which means I'm going down 2 over 1, down 2 over 1, so on and so forth. So let's start marking some of those out. Down 2 over 1, down 2 over 1, down 2 over 1. So there's my line there. Perfect. Beautiful line. And I know that solving systems of linear equations, I realized that, look at this. The lines intersect right there at the point 2, 4. So I go back and I say, okay, well, what was my x? If I go back to my original problem, I realized x was, let me go back here. X, I believe, was my pens, and y was my pencils. So my answer is, so I've got pens is 2, pencils. So I bought 2 pens, 4 pencils. Hopefully that helps you out.